Brendan again. This is going to be our second video on percentages. So in the last video I started to talk about the differences between percent increases, decreases, what percentages mean as a whole. In this video I want to go a little bit more into the whole percent increase and then a percent decrease, or percent increase and then a percent increase. So first thing I'm going to talk about is this idea of kind of accrued interest. And I'm not going to give you the formula right away, but we're going to build up to and derive and just show you how these interest formulas are simply reflective of subsequent percent increases. So what we're going to do is we're going to say that we have a bank account, and we're going to say that our bank account pays an interest rate of 7%. So the interest rate is 7%. What that means is that every year you're going to add 7% more money to the account. So essentially it's just a percent increase problem. You're going to have some original amount, you're going to increase it by 7%. So let's go ahead and do that. Well, remember from the last video that our final value is equal to our initial value plus our percent increase over 100 times our initial value. And the first thing I'm going to do is I'm going to try to rewrite this for you. And what I'm going to do is I'm going to see, okay, well, there's an initial value here and there's an initial value here, percent increase and percent increase. So what that means is I can actually factor out the initial value because it's common to both terms. If I factor out the initial, not equals, it's going to be a times here with parentheses, and then what do I have to multiply the initial by to regain this initial value? Well, I would have to put a 1 here, and then what would be here would be the percent increase over 100. So this is just another way to write the percent increase, percent decrease formula. Is that your final value is going to equal your initial value times parentheses 1 plus your percent increase over 100. And you can see if you were to use the distributive property to distribute that initial back in, you would just regain the equation that's right above it. But now I'm going to go ahead and use this equation. Let's say we want to figure out how much money is in a bank account after 1 year at 7% interest rate. And we're going to start with an initial value of $1,000. So we have $1,000. To that, we're going to take 1, we're going to add the interest rate over 100, and we're going to see that this becomes 1,000 times 1.07. And this would turn out to be 1070. Well, what if I want to figure out how much there is after 2 years? Well, during the second year, I'm now no longer taking 1,000 adding 7%, but rather I'm taking 1,700 and I'm adding 7%. So 1070, and I'm adding 7% interest. So times 1.07, we saw that that's 7% the one before. We go ahead and do this, and we get another number. Let's go ahead and figure out what that is here. So 1070 times 1.07 gives me that number right there. So it's not going to be $1,144.90. And I can keep doing this. I can increase it by 7% again. So I would just take this value, I would multiply it by 1.07. At this point, you probably get the idea that I can just keep multiplying it by 1.07 for every year. So let's say I want to figure out the fourth year. Well, going all the way back to the beginning, I could just think of this as being 1,000 times 1.07 times 1.07 times 1.07. We're going to run out of room here. Times 1.07, or times 1.07 4 times. So for that fourth year, I multiply something by itself 4 times. Well, we can think of this as being 1.07 to the fourth. And if we keep doing this, eventually we get to an equation that you may have already encountered in your Algebra 2 or Pre-Calculus or Algebra 1 class. And this equation is that your final amount in your bank account is going to equal what we call P, the principal amount, times 1 plus the rate you see it as rate in your percent class in your classes. So I'm going to leave it as R here, and all that rate means is the percent over 100. So rate equals percent increase over 100. And then raised to the t for the number of times that it happens. And this is really also applicable to the SAT. They usually don't ask you it directly, but they'll tend to give you this equation when they ask you questions about it. So that's still an important equation to memorize and be able to understand exactly what it means. All it means is that you're just doing a series of percent increases and percent decreases.